Hello. So, welcome back to Python Challenge for All. So, let's continue our work. Last time, in lesson 86, we found that A star, even a very wide A star, was not good enough to solve all 15 puzzles. So, we started to make something new. And for that, as a preparation, we started to make recursive DFS first. Okay, so let's continue our implementation. So implement recursive version of depth first search. Okay, so here, the code is like this. Just this one is just now uh, the very plain A star search. So instead of in solver, we start to make DFS. So for example, we don't need sort open for the time being, so we don't need it. We need eval start, maybe later, so just leave it as there and start from solver. So as last time, the starting status is this one. Tuple, yeah, make a list, which is a, this, oh, sorry, where is it? Okay. The first thing is let's define a starting path, which consists of just the starting state, okay? And then we will just give it to DFS, function DFS, which we will define from now. And, and the DFS should return something as an answer. So this is all we need, okay? Other things are just forget about it. So let's define here. Basically, it's like this. If the returned value for each new moves, yeah, we will implement this. So call recursive path, and then we will define the def of DFS given path. Okay, given path, it will first extract the last element as the current state. The last element of path is the current state. Okay, and if this is goal, yeah, to do that, that's yeah, like this. Okay, if stat is goal, we will write it here. If the stat is goal, then success. Okay, so it will return the path. Now we found the path. Okay, else, otherwise, yeah, it's simple as we did in the past. We will find new elements. Okay, we will make one tab back. Okay, so if it's not the goal, we compute the new states, and for each new state, do this. For each new next moves, call DFS next move. But before that, we'll check that if next move is already in the path, just continue. So it's like this. If, yeah, I should write new stat. So if new stat is in the path, we will do nothing. Okay? We will do nothing. Otherwise, new path is, okay, calculated. And then call DFS, the new path. Okay, this is all actually. Okay, so it's very simple. And again, let's do the same thing. the return value is added to assigned to ans, and if ans is something, just return ans, else do the next thing. Okay, try the next start. Okay, and then if everything failed, return none. Okay, this is just a very simple version of DFS. Okay, so in the, yeah, next move is the same. Very simple, right? Okay, let's check that. So the solver will put the initial state as a tuple to path and call DFS. This is all. Okay. Oh, yeah, right. We will check the same thing. If ans is something, then maybe we can write print solved. Okay. We will write something else later. But anyway, in that case, return. We will make the list version of states for s in ans. Ans, ans is now the returned ans is if the the path to the goal is in there. It's a path to the goal consisting of tuples. So changing each element into list and return it as a return. Else, maybe return none. Okay, this will work well with the calling position here because solver is called here from where when we strike S, it will give the initial state as a list and return a list of moves. So this should work. Okay, let's check that if this works for, yeah, this should be changed to 8. And let's check a very simple problem first, like 1, 2, 3, 4, 5, 6, 7, 4, sorry, 1, 2, 3, 4, 5, 6, 0, 7, 8. Let's try this and see how it works. There could be errors. Oh, it works. Okay. So S solved. Good. So maybe end space, space, space. Ah, I see. Okay. Uh, Seems it's working. So to see how much time it takes, we will make number of trials as global variable. So maybe we will have global variable n try here, which will be initialized as 0. And then every time we call DFS, we will add 1, 2. Yeah, okay, maybe we write global n try, and we will write n try plus equal 1 here. Okay, so that it will answer tries. After n tries. Okay. And then maybe we should print the list of ants. Okay. Um, uh, Maybe we should extract one from here so that um, the answer is here. Okay. Also, maybe we want to exclude the initial state. So maybe from 1 is enough. Okay, let's try this. Let's see how it works. So for this problem, okay, and S. Okay, solved 2 steps after 2 tries. Ah, strange spelling. 1, 2. Good, done. Let me try a little harder problems. Tries. Okay. So let us try a little harder problems. Seems it's working. So for example, if we have fixed n of 5 and we will try arbitrary question. Let's try that. Okay. For example, S. Ah, maximum recursion depth exceeded. So this is the problem. So what we see here is that if we have, for example, a fixed n of 5, we will see max recursion depth exceeded. This means the, yeah, kind of memory error that the depth of recursion is too deep. Let's try again. So for example, in this case, S will cause maximum recursion depth exceeded error, recursion error. So one idea to avoid that is to avoid try depth limited DFS, which is very simple. So let's try that. So when we call DFS, yeah, DFS here, if that's a goal, that's fine. Yeah, maybe before checking the goal, let's think how deep we are now. Okay, so for example, if the length of path is over 35, then we can just return none, meaning that the 30s fail and go try other options. This is, I think, good enough. Let's try this. This is called depth limited depth first search. Okay, let's try this and see if we can make a difference. Okay, S. Okay, great. 30 steps after 58,224 tries. And let's space. So it seems it's solving, but this is not optimal. It anyway found an answer, but it is not optimal. Okay, 32 steps. As we know, all 8 puzzles should be solved in at most 30 steps. So this is not optimal. But anyway, we could solve it. S. Okay, and okay, N, I mean. Okay, N, S. Okay, solved. N, S. Too easy. N, S. Okay, so maybe, yeah, okay, again. We found, well, suboptimal answer after long trials. You can try yourself, or you can try even smaller fixed ends. And it seems we cannot try, you cannot have good answers as well. S. Okay, 9 steps after 10 tries. N. S. Okay. Yeah, it takes time. So it is not very good. It can solve only easy problems. So let's see what we can do from here in next session. Okay? So be sure to come back. Bye bye.